Okay, welcome back to the UAM Noise Working Group meeting. Very happy to have with us this next panel session with a number of great panelists representing the industry both in the U.S. and outside the country. Just briefly, as we'll go through, our panelists are Ben Goldman from Archer, Jeremy Bain from Joby, Yahia Ismail from Supernal, and then online we have Heinemann from Lilium and J.D. Terry from Textron eAviation. And so we'll be hearing from those folks in just a few moments. If you recall, the way this is going to be structured is we will have opening remarks, about 5 to 10 minutes from each of the panelists, and then go into a moderated Q&A session. In that Q&A session, we have solicited a number of questions from each of the 4 subgroups, and those will be the questions that will be asked of the panel. Each panelist will be given an opportunity to answer those questions. And then following that, we'll have a open Q&A session for about 30 minutes or thereabouts. I would like to just make it known that there may be some members of the press in attendance, either here or virtually. We will be recording this session for later viewing. Hopefully that'll be posted on the NASA YouTube channel. And you may post your questions at any time, but please, if you do so, direct them to a particular panelist so that each panelist can have an opportunity during that open Q&A session to speak to a question directed towards them. Finally, while we are taking questions all along online, I will only ask the audience here to participate in the open Q&A. If you do see something online that is of interest to you, please upvote it with a thumbs up, and we'll be able to get the most relevant questions asked. And so I think that covers my opening remarks. And without further ado, let's go ahead to Ben. So Ben is here representing Archer. Ben has had quite a interesting career, first starting out after graduating from Purdue, my alma mater, and then Penn State, with Bell Helicopter first, and then a couple of years at Joby, and then at Archer presently. And that speaks to a lot of experience in this area, and we're very happy to have him. His role at Archer is he's responsible for the design of the vehicle, noise from both an interior cabin perspective and from the external environment, which I think is of most concern here, and that directed toward the production vehicle, which we'll hear about in a moment, the Midnight. And so without further ado, Ben, if you would give us your presentation, we'll cue that up.
Yep. Yeah, I don't have much to say, mostly just what's in the slides.
Okay.
All right, I guess I'm speaking to it. So there's been a lot of video, a lot of imagery put out about the vehicle in the last few months. This is our production vehicle. We are planning to certify 2024. We are intending to be the first company to commercialize eVTOL travel. There's certainly a number of companies that are competing for that same timeline, but in fact, just this morning we announced a new route. We've already announced our route in Newark, but just this morning we announced that we are also establishing a vertiport out of the Chicago hub. Next slide, please. So we are designing, certifying, manufacturing an electric vertical takeoff and landing aircraft, eVTOL. Our mission is to unlock the skies, and we are trying to reimagine how we live and spend time. So we are trying to provide a transformative travel experience The fact that this vehicle takes off and lands vertically, it allows these operations to integrate more easily into cities. You certainly don't need runways in the same way that conventional takeoff and landing needs. The all-electric powertrain means that we have fast charging capability, lower direct operating costs, maximizing utilization, and of course safety based on redundancy, both in batteries, motors, and zero critical points of failure. Right, so as I mentioned, our target timeline is airworthiness certification in 2024 and commercial ops in 2025. So as I mentioned a couple slides ago, we are targeting safety. That is our #1 priority, safety and community trust. So no single points of failure. We have a distributed electric propulsion system, multiple redundant propellers, multiple redundant motors, multiple redundant batteries, all powering the systems. Quiet, that's why we're here. We are trying to integrate quite closely into communities, so obviously we're trying not to increase the ambient levels based on these operations. And during typical operation at 1,500, 2,000 feet, these vehicles will blend entirely into the background. Sustainability is also a huge target. The ability to produce zero emission helps advance global decarbonization. We're certainly not trying to add to a footprint that drives up that pollution. And of course, affordability is also key, because if we're not able to provide something that's lower cost than what's already available, there's no sense in transitioning. So these electric powertrains allow for a reduced maintenance, lower energy costs, lower overall cost of operation. So just evaluating the industry as it currently stands. I don't remember the current count of how many companies are currently in the running. Is it 100? Is it more than 100? Many. It's a lot. A lot of different ideas. Certainly a number of them are being boiled down, and there's certainly a number of common platforms that are being at least currently recognized as high-level contenders. When you filter that through in terms of available capital, looking at fixed-wing aircraft, which allows for increased range, lower noise, higher speeds, the ability to integrate into a mobility market, so looking at city centers as a focus, and then pilot operation, which is what is currently available through type certification. That really boils down to just Archer and Joby. So the business case, we are looking for a 4-passenger vehicle, typical 20-mile back-to-back missions. Certainly the vehicle is capable of longer ranges than that, but a common mission, our standard mission is about 20 miles back-to-back. We are targeting over 1,000 pounds of available payload. It is laser focused on certification, so everything we are doing is TRL 8 and up. We are not looking to design anything that the FAA is going to gawk at. This is all what's already off the shelf. The in-house development of a couple key enabling technologies. So commercial off-the-shelf powertrain is not something that is currently suitable for our power needs. So we are developing our own powertrain systems, but we're looking to bring a safe, sustainable, accessible aircraft to market via an efficient path to certification. I think I mentioned all the key requirements already. All right, so we are looking at a data-driven model. We are using data modeling to predict the UAM demand. That helps us inform location of vertiports, obviously the design of the vehicle and the mission. So the sizable market opportunity in 10 to 50-mile routes is key. Ground transportation in those areas that we are targeting takes upwards of 60 to 90 minutes, so that allows us to offer an incentive in terms of time savings. Optimizing production aircraft, it will allow us to provide these rapid back-to-back 20-mile missions with minimal charging time in between. That enables us to keep profits up while minimizing downtime of the vehicle, and again, lower direct operating costs in order for us to actually make a profit. So, widely announced, we are partnering with United Airlines. They are our flagship customer at this point. We entered an agreement with them 2 years ago, 2021. So they are offering $1.5 billion in aircraft sales. obviously pending the delivery of our vehicle through type certification. So in April, we formed a joint eVTOL advisory committee to support those operations. And that includes both the maintenance and operational standards. We've gotten some pre-delivery payments, which is great. It just indicates that Archer is confident in our progress and how we're developing the aircraft. And in November, we announced the first UAM routes. That is the downtown Manhattan heliport to Newark route that I mentioned. And just this morning, so not included on the slide, we've added Chicago to that list as well. So commercial ops. I mentioned the 10 to 50 mile distance is our target within pretty dense city centers where ground transport usually takes about 60 to 90 minutes. Early markets are going to focus on utilizing existing and retrofitted infrastructure, not trying to build out vertiports directly, but use what's already there and then build out as we can. So highly congested cities, New York, LA, Miami, obviously Chicago. And these routes will be a trunk from airport to city center where we know there is a demand and thus a willingness to pay for those routes, and then follow a branch route once we've established those hubs. All right, so we are working our way through certification. We started in 2018. We're making very good progress on that side. So we are optimizing business midnight for a business case, intending to type certify in 2024. The early operations from 2024 to 2028 will build out those operations based on, as I said, a trunk and a branch, hub and spoke, however you want to call it, using existing helipads and ports as they are currently available, and then building out as the design and land use becomes available. Scaling up from manufacturing, target about 2,000 vehicles a year long term, and then mass market, looking at volume manufacturing, high rate of operations, certainly moving towards autonomy as that becomes available, but starting out with a piloted aircraft, as I mentioned, and then continuing to improve on the design. I mean, we say internally that this first vehicle will be our worst, and then all the rest of them will get better from there. So improving on the engines, on the battery performance, on the acoustics. And that's all I got.
All right, thank you, Ben. Brenda, turning it over to you.
All right, let's move on to our next panelist, which will be Jeremy Bain. And Jeremy started out at Georgia Tech, getting his master's there. He stayed on for a few years as a research engineer. He then moved on and consulted for a few years after that, and he joined Joby in 2017. He now is involved in the design and analysis of that vehicle. Jeremy, welcome, and I will not take any more of your time so you can talk.
All right, thank you very much. All right, so glad to be here this morning. Jeremy Bain. Working with Joby for quite a while. Really looking at trying to introduce this new technology to as many people as possible. So we do have a nice lawyer disclaimer. Different lawyers, different groups, but it's kind of funny. But yeah, lawyer disclaimer. We can move on. So Joby, is another one of these companies. What makes us a little bit different is we're very vertically integrated. We're trying to do almost everything ourselves. From the motors, propellers, airframe, electronics, the batteries, the battery packs. We don't make the battery cells, but make the battery packs. Almost everything we're trying to do ourselves. So that's obviously a big challenge, and that's part of why we have more than 1,000 employees, well more than 1,000 now, spread across various locations in California, Washington, D.C., and then Europe. We have a growing group there. So we're trying to do an app-based aerial ride sharing where you can book it through our own app. So we're going to try to develop it, test it, and then operate it ourselves. Next one. So here's a nice boilerplate. You can piloted aircraft, 4 passengers, vertical takeoff and landing, all electric. 150-mile range, which we have demonstrated in flight test. 200 miles per hour, which again we've demonstrated in flight test. And this aircraft's more than 10 years in development. And then last year we flew over 10,000 miles. There's a pretty neat animation on LinkedIn of all those flights. A lot of flying circles in the sky, some clockwise, some counterclockwise, some probably inspired by NASCAR racetracks. But we flew our logo too. But really just trying to fly as much as possible to prove out the aircraft, its endurance, make sure that the life cycle and the maintenance is reasonable, that all the parts can fly as much as we can. Next slide. So again, our partnerships, almost all these companies are partnered with an automotive company, which I think is great, which really speaks to how we're trying to mass produce these aircraft in operations and in numbers that, a company like, we haven't built aircraft like this in these type of numbers since World War II. And really that's where the automotive companies really come in with their supply chains and their mass manufacturing capabilities. Our go-to market strategy is partnerships with both Delta and Uber, so that you could book our aircraft through the Delta app or through the Uber app, or you can book it through our own app. But partnerships with those companies help really get you an early partnership and really help build up your volume. Operations, we've been partnering with the U.S. Air Force through the Agility Prime program. That's been really wonderful. Provides us with great technical expertise, testing, and really unique partnership to, for our aircraft. So again, we do plan on having an app. So go through our nice app, and the first leg or the last leg might be an Uber, or it might be another ride sharing, and then you could book this through our own app, or in select cities you might book through the Delta app or through the Uber app. So we do have, this is our acoustic slide that we share to non-technical audiences. So trying to get people some understanding of what noise levels means. What does 60 dBA mean? What does 80 dBA mean? So in cruise at 500 meters overflight, 45 dBA, which we've demonstrated. At takeoff and landing operations at 100 meters away, 65 dBA, which again we've demonstrated. So that really tries to blend in with the environment. Really, it's quantum leap difference from helicopters. And then also, in order to get mass production, you have to have economics. And so this is, typical operating, 25-mile flight closer to $100. Next slide. So I did want to share a little bit some of our technical papers that we published. We've been trying to be more open as we've gotten on. So this is a fun little paper, but we ended up, for this paper, we didn't have access labels, so it's kind of hard to see what was actually going on. But this is a cool wall of different blades that we tested. So all these different geometries we tested, we built ourselves, we tested ourselves for acoustics and for performance. And really what we were looking for here is, how low of tip speed can you go? What is the difference in solidity? So if you look on the far side, there's a really skinny blade that obviously, in order to get the required thrust, had to rotate a lot faster. And then there is a very large solidity blade, which could spin a whole lot slower, but you're at areas where you didn't get the acoustic benefits that you really could get. So you had some compromise between cruise and hover, performance and acoustics. But obviously, the blade we chose is pretty high solidity, and it's a 5-blade design. So then last year at VFS, we published actual flight test measured noise. So this is a flyover at 95 and 100 knots. And we did just at our remote test flight facility, we were able to obtain various other aircraft, and we flew them all one after another at 1,500 feet, 100 knots. And really it sort of gives you the feeling of what the aircraft means and what the noise levels means and how it feels and how you hear it. So that obviously is a very remote location. So the background noise was pretty low, although if you notice that after like 20 seconds on one of our flights, it went up. That was because of a commercial airliner in the area, which bothered me at first until I figured out why it was. But going over to the spectra, the background noise is obviously very low here. But if you compare it to a more reasonable background of an urban environment like a cafe, we've all been eating outside at restaurants during COVID. And so, it's not an incredibly loud environment, but there's people talking, there's people moving around. And when you compare our spectra of the overflight, we're below or at that level, and it's very hard to hear our aircraft distinctly. And then when you compare it with a helicopter, it's obviously much more tonal. It stands way out. And then now I think we'll try to play a video, if we can. So this is on YouTube, but this is sort of just the flyover noise. Yeah, so I mean, that's flyover noise, which is great. And that's why we're not as concerned with flyover noise, because we think that's, flies over a city. Most people aren't going to hear it. We're much more focused on takeoff and landing noise. So if you go to the next slide, or I think that's, we did have a paper by Alex at the VFS that really showed some of the design evolution of our aircraft. This is a really cool picture I was glad we were able to make and show. So in the center is this quarter scale model that flew in 2016, which, when you think back, is actually a pretty long time ago. And then on the other side, the all-white aircraft is our first full-scale prototype aircraft that flew in 2017. And then on the side is our pre-production prototype, which is started flying in 2019. We're still flying every day, pretty much. And then yesterday there was 3 presentations that mentioned our data. Alex posted, or Austin showed some results of our computations comparing to the flyover noise. And then Kyle and Mary showed some results of our data and some use of their data from the National Campaign Flight Test. I do highly recommend reading that paper and getting it. It's available on the internet, just anybody can get it. But we showed not everything. Obviously, we flew for a week. There's a lot of data in that flight test, and we're trying to be open, but we're not showing everything. But we're showing some real numbers. So here's one landing that was in the paper, just a ground contour of LA Max. On the next slide. We also showed hover noise levels, both in ground effect and out of ground effect, showing we're below 65 dBA at, this is 350 feet, but 100 meters is pretty darn close. And then we do show some spectra at 50 knots. You can see, at 50 knots, you're a little more tonal because you're a little more like a helicopter because we're at like 40 tilt, or 40, 50 tilt. But still, it's dramatically different from a helicopter. And that's really what we're trying to focus on, is more blending into the environment in our takeoff and landing noise. Next slide. So future possible papers. Right now we're in NFAC. This image was released. There are microphone test stands in there right now. So we're going to gather performance, loads, and acoustics at the NFAC. And we're going to publish some of our validation data. Some other organizations will probably publish validation data too. But we're not going to openly provide all the geometry to anybody who asks for it, or we're not going to provide it openly to academia, for example. But there are some organizations that will get access to the data to validate our tools and trying to understand what the tools do well at and what they don't. We showed flight test data the other day, and a lot of questions about different noise sources, so hopefully this test will help us understand better. And then we do plan on publishing more about the national campaign and our validation efforts to try to show what the tools do well, what the tools could be improved, and really what we hope other organizations will develop future tools and improve the tools. So I think that just another great picture of our aircraft. Thank you very much.
All right, we'll move on to our next panel member, Yahia Ismail. He did his PhD at Old Dominion. He then did his postdoc. Following that at Notre Dame. After his time at Notre Dame, he moved on to Boeing. Following Boeing, he worked outside of the aerospace industry, working on a lot of acoustics and vibration problems. He also worked at Aurora Flight Sciences, and he joined Supernal in 2020. So Yahia, welcome to the panel.
Thank you, Brenda. Good to be here with you, and would be glad to share with you some of the Supernal story. I'm Yahia Ismail, and from Supernal, as I mentioned. First, before we get into what is where we are, let us see what is the challenges we are facing now. Could you go next slide, please? What is the ground transportation challenges we have in some areas? Is very like LA area or Chicago, probably New York City, where it's very hard to move from one place to another, especially during the congestion, very traffic times. And the problem is getting no way is getting be solved in the near future, and it's getting worse and worse. So urban air mobility is one of the solution for ground transportation challenges. So luckily, we are living in a technology era where electrification in the automotive side, automation, and the big data and the ride sharing is everywhere around us, which are very basic elements in urban air mobility or advanced air mobility in general. So several companies are racing to provide new mobility solutions, and those are some of those companies. So air mobility is a key piece of this new reality we are facing. Helicopters, as we all know, is very loud, is not really a good solution, and is not available for everyone, very expensive to use. And actually, in fact, only 11% of the world population is using current, flown on aircraft in 2018. So there is a very big opportunity for us to use air mobility as in the market to fill this gap. And there is a potential, high potential growth for the advanced air mobility from now until 2040. That's what I would say forecast, very massive potential for that market. So many companies, of course, are leading the efforts in this new era of mobility, and those are subset of the companies are working in urban or advanced air mobility. There is multiple use for advanced air mobility. Many of us maybe think about urban air mobility as just one use. There is some other uses like regional air mobility and non-commercial services. So average transportation user is likely unaware of advanced air mobility. Whenever I ride like with Uber or Lyft driver and I ask, he will ask me, what do you do? I say like I'm working in air mobility. He will be surprised because they're more familiar with the ground transportation, but still not familiar with the air mobility. So what is the target for urban air mobility or advanced air mobility? Of course, urban and suburban communities where the problem exists and demand reliable, efficient, multimodal transportation kind. And of course, the constraint, the prospective user is constrained by the congestion and rising cost of living. What are their perception? Largely unaware of, as I mentioned, of advanced air mobility, likely have never been inside a small aircraft, frustrated with their limited transportation options. What does it mean for OEMs? People cannot support what they don't understand. So we need to educate the people. And people cannot understand what is not tangible. So we need to show them what is available. And there is significant demand for reliable, efficient transportation. So that was good introduction before get into Supernal. So Supernal is part of Hyundai, the mother company. As you know, Hyundai, Kia, and Genesis possess like cost-effective, high-quality mass production of vehicles from the automotive industry. And there is, at the same time, diverse capabilities for urban air mobility infrastructure and financing through Hyundai and Mobis. Recently, Hyundai acquired Boston Dynamics and Motion, which is very important pieces in the advanced air mobility solution. So the result of these unique strengths and capability is a fully integrated mobility solution. Provider that is well positioned to build advanced air mobility market. So what is Supernal? What is the long-term? Supernal is making long-term commitment to advanced air mobility, and these are the mission for Supernal and what is Supernal vision. So what is our entry into service, the timeline? 28 is our entry into service target date. Despite the progress in the industry, all companies will need a clear pathway for infrastructure development, which is vertiports, of course, one of the vertiports is part of this infrastructure. Public awareness and acceptance, especially in the noise, polluting these communities. So we have to have some sort of awareness and acceptance, and clarity on multi-jurisdictional governance and coordination, and a roadmap for multimodal integration. How we will move the people from one point to another for the vertiport within the urban community or suburban cities. So what is the Supernal design pillars? We have 4 design pillars: safe, quiet, affordable, and passenger centered. So these are the main design drivers. We are building our vehicle based on those 4 pillars. So of course, it will require building a whole ecosystem for advanced air mobility, which will seamlessly integrate with the cities, starting from the vehicle, going to the vertiport, a hub, and modular ground transportation, moving the people from one point to another point. So in order to achieve this, we have to continue engagement with partners and the stakeholders. Advanced air mobility market will require some sort of engagement with regulators, government agencies, travel and tourism industries, airport, federal, state, local lawmakers, academia, research institutions, and of course other suppliers and integrators. So focus now, what is the focus now on addressing the needs of a diverse group of stakeholders? There are a group of stakeholders and they have some concern. What is the concern? Of course, funding is one big concern in the advanced air mobility, or regulation in general, public acceptance, conflicting timelines, roles and responsibilities, and customer demand. So what is the value proposition? We are offering emission-free environment, and we can solve the congestion problem in some urban environment. In infrastructure costs and lost time of the people moving to their commuting to their work or moving from point to point. At the same time, we are increasing the social prosperity of people by providing this alternative transportation system and the capacity in the network, productivity of the people, and of course, economic value from the advanced air mobility. So lastly, I would like to talk about the collaborative partnership which will enable to achieve these goals. So all this is very important to work together is a very big challenge, and without this collaborative partnership, I think it will not be easy to get into the market, whether it is a regulatory pathway like FAA or EASA. We were talking about the regulation certification kind, accessibility, advanced technologies development, affordability, and the scalability. So these are the goals which we try to achieve. And that's all, and thank you.
Okay, thank you, Yahia. Next, turning our attention to our online panelists, we'll introduce Till Heinemann from Lilium. Till, hopefully you can turn your camera on in a moment after I get through the introduction here. Studied mechanical engineering at Erlangen University and was working in industrial fans for quite some time at the beginning of his career, even as a postdoc, then transitioning to the German Power Plant Engineering Bureau, and joining Lilium in 2018. And at Lilium, he engages in a number of topics, including commercial and certification, to noise development plans, technology or technical strategies, design, model development and validation, experimental strategies, and B&B activities. So with that, Till, if you would come on camera and give us your overview presentation.
Yes, hello. Can you see me?
I'm not sure. We cannot see him from there, but you can see him. Those that are joining, we can see you through the Teams, and then we'll bring you on during the Q&A. So please continue.
That's fine. Yes. Hello and greetings from Munich. I'm very happy and honored to represent Lilium on this panel. And I was just going to give you a very quick overview on our aircraft, our company, and our recent or our general activities in terms of noise certification and noise emissions. Can you go to the next slide? Yeah, thanks. As you see, and maybe some of you are familiar with the design of our aircraft. This is a ducted fan distributed propulsion system that we see here of 30 propulsion units mounted in the flaps of a main wing and a canard wing. And this gives us the advantage of reducing the drag quite a lot. We can fly quite far and fast and with a low noise profile, which is especially advantageous in cruise mode to the passengers, since you are shielding your noise a lot, but also you're shielding it from the environment by the mounting of the engines on the upper side of the wings. This will be available in 5-seater and 7-seater configurations, and of course fully electric and built according to highest safety levels. The configuration you see here in the picture is the cruise mode, meaning the engines point backwards, generating thrust to overcome the drag, and the lift will be generated by the wings, by the main wing and the canard wing. Obviously, when we're flying like this and we transition into landing, the flaps with the engines are going to rotate downwards, pointing the thrust towards the ground. So we decelerate and come into a nice hovering flight, where then the engine will be, the aircraft is hovering through the thrust of the engines, and we take off and land vertically. Can we go to the next slide, please? Okay, the business today is two parts, both a design organization and production organization. We are currently employing over 800 employees, and most of them here in Munich, and we've obtained over $1 billion of funding listed on the NASDAQ. And I think this is a recent figure, 640 pre-ordered aircrafts in the pipeline so far. There are a few impressions of our company here. On the top left, maybe most interestingly, is one of our demonstrator aircrafts flying peacefully in Spain. I believe you see our production facilities, and I think that's a picture from last year, but this is in Munich on the lower left. You see the semi-anechoic testing facility for our engine system, for our propulsion system. And yes, maybe let's move on and look a little bit towards flight testing. Exactly. So I think only 2-3 weeks ago we achieved 250 kilometers per hour, and so top velocity with the demonstrator, one of the demonstrator aircrafts. The two that you see there standing on the left-hand side, they are a bit more than a third the mass of the type certificate aircraft that we're designing, and you will have noticed that they are very, very similar in architecture and design. So those flight tests do give us a lot of information, a lot of benefit to support our method development, our tool development, not only, but of course also with respect to aeroacoustics, and to also support certification activities, to know what we can do, how we do it, to improve our current design of the aircraft. And maybe, I hope this works. You can play this video to the lower right that some of you may have already found also on the internet.
Max RPM on ground. Lift off. Limiter.
So you see the hovering mode and then flaps going into transition.
Next step is 100 feet.
Into forward flight. You see with the tufts how the main wing attaches
Altitude is good
first.
to cross.
How the canard is second.
Right turn. Heading 340.
It's still detached.
Okay. Speed is good. You can accelerate to 95 smoothly. 3, 2, 1. Clear for a steep climb. 10 degrees. Stable.
Stand by. Clear to proceed.
Diesel and level off.
Okay, thanks. Next slide, please. Yes, talking about engine level, like I said, we have a lot of testing also on the individual ducted fans propulsion system, which helps us to validate our numerical source prediction tools, as well as give input to flight prediction based on engine data, which then again we can of course validate with the flight test data we have, and which gives us a very important piece of the puzzle. Next slide, please. Talking about certification, with respect to noise, we're aspiring to certify in 2025. And for noise, we are categorizing with the Chapter 13 of the Annex 16. We are quite far, I would say, with EASA in the discussion, in the process to define the conditions. So it's obviously Chapter 13 is EP&L in takeoff, including climb, overflight and approach, three distinctly defined conditions, which we are deviating to a certain degree from, and this is part of the process because of airworthiness. Our design is, as you have seen, quite different from traditional tilt rotor aircraft, so there is some aspects of the definition of the operations that we cannot do or that don't make sense for us to do. So this is part of the process right now to hopefully quite soon issue a so-called environmental special condition for our noise certification. So this will describe the deviations from the standard chapter 13 process and publish that. It will be available then. Any stakeholders publicly can give feedback and criticism and any inputs to that. It will then come back to EASA to be worked over, and when finalized, that will be the basis for our certification plan, which can be defined after this special condition process. Next slide, please. Besides certification, of course, local stakeholders are super important for our operation. I've just been in a meeting this morning with the German authorities from Umweltbundesamt, so the environmental ministry, and the Verkehrsamt, Ministry of Transport, who want to know like how do we apply and adapt noise regulation, but for now it seems we are on a good path with the equivalent noise levels that exist as urban thresholds. So this is obviously an important business criteria for us to derive the acceptable distances from flight paths, the number of takeoffs and landings, and derive our maximal design targets for noise as well. While these are averaged overall metrics, we also have a strong focus on the maximum noise events that obviously occur when you take off and go into transition. I think for all of our aircrafts, and the tonality, of course, is also of interest. Next slide, please. That yes, you may maybe read later, and that concludes my brief introduction of Lilium. Thank you very much.
Very good, Till. We appreciate your participation here remotely, and that came through just great. And so,
sorry, I hope it worked out. There's quite an echo, I think, that I hear from my speakers. I hope it was audible in the room, though.
It was fine. Thank you.
Just for like some people in the Zoom call will maybe have heard that.
Yeah, it might be feedback on our mics, so perhaps we can duck them. So on our next and final panelist is J.D. Terry, representing Textron eAviation. And Textron eAviation is got a lot going on in various sectors. It is part of Textron. It's an initiative that was to develop new opportunities leveraging both fixed wing and rotor expertise in the company. And as you'll see in JD's presentation, there are a number of different aircraft. The focus here is on the Nexus aircraft, and JD is responsible for the engineering of that vehicle. He's been with Textron for many years, as you can see, and began his career in avionics and was later chief engineer for CJ Series, and now is director, or was most recently director of engineering for special missions and defense. So JD, welcome, and we'll get your presentation up here in just a moment.
Morning. So first, as you're pulling that up, I want to say that just with the panel, reading the bios and all the expertise there, it's just quite amazing to be a part of it. When Royce asked me if I was interested in doing this, of course, you know, I don't have a background in acoustics, But he said, you know what, we want a background from a chief engineer and what the chief engineer is thinking on the multiple projects that are going on right now and with the Nexus. And I was like, sure, I can do that. That sounds no problem. Right now I'm in Wichita, Kansas, and I am in the glass house, what we call the glass house. For those familiar with the Cessna product lines, pretty much every jet and prop was designed out of this building. And that is where we are now designing the Nexus. You can go to the next slide. So this is just kind of what we're going to go over. That gives you just a good picture of what the Nexus itself looks like. And we can go to the next page. So right now, I mean, there's lots of conversation, lots of different questions about how does Pipistrel, eAviation, and Nexus work together. eAviation is a part of Textron. And then we have Nexus, which is a family group that feeds into eAviation. And then Pipistrel is a family group that feeds into eAviation. We're going to go through a couple of the different aircraft that we have going right now, and we're looking at certifying and how they pertain to noise as much as we can. And with that, we'll go to the next slide. So the first one to go through, probably most people are familiar with the Velis Electro. It is the only type certified electric aircraft in the world. It is EASA certified. I have had a chance, we actually have one of these in our flying club for Textron Aviation right now. Had a chance to be around it quite a bit. And for those that haven't, it is quite incredible how quiet the aircraft is. From a forward perspective, a side perspective, and when it's flying over your head, just incredible what they've been able to do with this. This also gives us an opportunity to take a look at Pipistrel's technologies and share information back and forth, which there's been a lot of. So pretty much everybody on my staff has been to Pipistrel and gone through everything that they have, and vice versa. We have them over here all the time too. So far the relationship has really started off with a positive note. We can go to the next slide. This one really doesn't have to do with anything electric as far as where we're going with it right now. The Panthera is very similar to the Cessna TTX. It's considered a hot rod. As you can see with the engine in it, the IO540, which is Lycoming, which is also a Textron Aviation company or Textron company. But the thing that's pretty neat here, and I've had my chance to get my hands on it and take a look at it, is it also has a hybrid technology that they've put together where it has both an electric and a gas engine to power it. There was a lot of stuff stuffed in the front of that, but again, I think it's the first of its kind out there. And it worked. I mean, I was able to get my hands on it and take a look at it. We'll go to the next one. So the Nuva is a pretty slick aircraft too. Again, I've had my chance to get my hands on parts and pieces of this, of the major structure of the airframe. We should have one all together and hopefully first flight before the end of this year. And what's kind of neat about this is they've taken the technology of the Velis, the electric engines off of the Velis, and put them on the fuselage, so there's 8 of them. And then it has a common Rotax pusher on it, which can charge the batteries, and it can also be used as a pusher. And this thing right now is good for about 1,000 pounds. So depending on the altitude that you fly, 1,000 pounds is what you get out of it. And we all remote. So we are looking at full autonomy, which everybody is. But right now the plan is to fly these from the ground. And most of this project is being done from the Pipistrel side of the house. But again, expertise as far as when they come up between aero, controllability, the acoustic side of it. Some of those experts from the Textron Aviation side and the eAviation side are helping and participating in this aircraft too. We can go to the next slide. So Nexus is the biggest piece, or the biggest thing that I have. So I have all aspects of it as far as the electrical, aero, avionics. For propulsion, basically everything on it. We have about 60 people right now that are working it. But what's unique about it is, it started off with Bell. Bell infused DNA from a helicopter into it. And then as it came over to the eAviation side, which the majority of participants on eAviation are from Textron Aviation, which are, used to either the prop side of the house, but most of us were jet people. We were able to infuse the DNA of the airplane into it. We have cut our first parts for this. We're planning on having the majority of it together by second quarter of next year, planning on first flight test end of next year. The other thing that's kind of neat about it is right now, which makes us a little bit unique, where even on our jet side, we still make, almost 90% of all of our parts in-house. We're able to move pretty quickly on the build process. So all of our major tooling is coming together. It's an all composite airframe. Of course, we own our own autoclaves and all the technologies with Scorpion and some of the Beechcraft aircraft that were done in the past. So we are moving quickly on this aircraft. Next slide. So timeline for certification, again, these are notional. This is what we're thinking is going to happen. So right now, I just put this up because we have a forefront battle as far as certification is concerned. So the Velis Electra is a light sport category. That light sport category is certified in EASA, but for it to be certified in the U.S., the way that the U.S. rules are written for light sport, it says one reciprocating engine in the regs, and we are trying to work with the regulators right now to get that changed to one electric motor is also acceptable. So we're hoping that that will happen sometime before the end of the year or into next year. The Panthera, which we went through, the gas version should be certified. We're thinking end of 25. There's work to be done on there, but we've already fielded, I think it's like 15 or 20 of those between stateside and overseas or in the Europe realm. So lots of data being collected there. Originally, it started where you could buy it as a kit. Again, it follows the exact same path as TTX, but with their expertise and our expertise in certifying Part 23 aircraft, we feel that we can be able to handle that. NUVA is, again, it's kind of out there as far as, yes, we're going to be flying it before the end of the year, but there will be lots of testing. And just like everybody else, we are waiting on regulation and trying to understand what the regulations are going to tell us. But again, it is being designed from a certification side of the house or certification thought. And then again, it will just have to wait to see where regulations are going. And then again, on the Nexus, we are more in the 2030 range. But again, everybody on my staff, pretty much, we probably have over 200 years of experience in aircraft certification. So we believe the biggest hurdle for all the aircraft companies out there is going to be certification. I'm not saying it's an easy task to make something fly, but it's not hard to make something fly, especially with today's tools. But to get it certified is where all the rigor comes in and the actual pain points. As I tell most of my engineers, of the entire build process, 25% is the engineering to design the aircraft. There's another sliver in there that's, figuring out how to get it built. And then the majority or pretty much everything left after that is how do you certify it and what are the tools that you use to certify. We can go to the next slide. So I threw this in here just a little bit about me and what I've done in the past. When I first started off my career at Cessna, of course, I couldn't afford an airplane. Wanted to get something just to get myself up in the air. And I ended up going in with 4 engineers, or actually 3 other engineers and myself, to buy a Benson B-8M gyrocopter. Again, I don't know if it was the wisest decision that I've ever made, but the reason I bring it up is because there was a story behind it where when we first started flying it, we didn't have a motor yet, and we would fly it in what's called kited. We had basically a big rope, about a 200-foot rope that would go to the front of it, and we'd stake it down to the ground. And the Kansas wind, when it's windy enough, you could get the rotor moving fast enough where it would pick up enough speed where you could go up, we would be above the power lines with it. And as long as you kept tension on it, you could keep flying and you could move left or right. But I think the thing that I learned there early on that I didn't really even realize that I had put something together until this project came along is even without an engine on this thing, the propeller was still loud. And I think that was just, something that, again, I realized that back then. I didn't think it'd ever matter anywhere in my career because I was never going to work on anything with that big a rotor on it. But it did, and I know that there is a lot of expertise that have to go into being able to quiet a vehicle down, especially in what we're doing right now. So with that, I'm just saying that for the group that's on the panel, for NASA and putting this together, what you're doing is of huge consequence to everything that we're putting together here, and I just appreciate what you're doing. I appreciate the expertise of on our side from Bell, from Roy Snyder, and then also, Scott Sanborn is another name that I use all the time in my previous life and on the jet side and on the prop side. But again, just a shout out to them to say thank you and to the rest of the panel. This makes a difference in what you're doing, and especially to the industry and to other, bigger companies like Textron Aviation. So thank you. Go to the next slide. So one of the things that we have that's quite unique from everybody else is we have Macaulay, and then we also have Bell, who have designed all their own rotors, propulsors, and propellers. So for us, when we start talking about noise, we get into their databases. And what's kind of interesting about their databases is they don't look at as much at noise in the past. So some of that, we're having to go back and verify what we believe our databases are telling us, what our programs are telling us. And in the end, we're going to have to actually get out and do tests, just like everybody else. So we aren't exempt from just like, hey, we have this secret formula for noise. We don't. But again, on the next slide, I can show you what we're doing, which is very similar to everything that I'm seeing today. So we can go to the next slide. So on the right is the main thing that I want to hit from this slide. That's actually almost the diameter of that. I think each blade on there is almost 12 feet on this one. We have a bigger stand that's coming together, and then we actually have a smaller test stand that we've put together too and done testing on it. And kind of the idea is we can take our known props that we have, again, since Macaulay is basically a stone's throw from the building I'm in. They can go dust off any of their props that they have. They can give a recommendation or a thought of, hey, here's what our prediction is on how loud it's going to be. And we go ahead and put it on the test article, and then we can verify. Now, again, in a lot of the test methods that I've heard today, even talked about, I have even more questions than I've ever had for some of the experts in our group, but I would think that we would be utilizing a lot of those standards here pretty soon too, and how we're taking our noise measurements. The only other reason that I put the Velis on here is just to make sure that I mentioned again that it's 60 dB. I mean, the thing is absolutely incredibly quiet in what it does. That motor is what's turning our small propulsor right now. And that's what we're using for collecting data through the entire transition, and also on, we have it running on a truck too, so we can get side loads on it too. A very standard practice and what a lot of the other people are doing. Go to the next slide. So as a chief engineer, just kind of the things that I'm looking at, or I'm having my people brief me on as far as, the acoustic side of the house. These are the documents. I won't read them off. You all know them, probably way more familiar than I'll ever be with them. I would say that on the very last one, RD 77-27, in the last 2 years, that hasn't, the FAA is not accepting that anymore, or it doesn't seem like they're accepting it as much. And for us, that does run into, cause some problems, especially if we're doing DoD or something that's not stateside, where we are doing a modification and the aircraft can't come to us for testing. As it goes now, in the last year before I took this job, everything when we would do, some type of bump or, as I say, war off of the aircraft, I would say we just need to test. We're going to have to test. There's no way that we can show, that it's not needed. With that, we can go to the next page. And this is just kind of the last slide. It had an embedded video. It was my fault that it doesn't work. This was one of our booms that we have currently on the Nexus. And what we were looking at is the aft propulsor, which is a two-bladed prop, and how it went over essentially the boom itself, and predicting what we thought our noise was going to be off of it. With this, we are, again, on our big propulsor test. We will be making it where we can put multiple shapes on there to try and verify the predictions of what all of our databases are telling us. And that's it. I appreciate it. Thank you.
Okay, thank you, JD. I'll just throw in there that I had the pleasure to ride in that Bellis last year, and it was quite a sporty aircraft. So if anybody gets an opportunity over here or in Europe, catch a ride. So we will next move into our the next segment, which is our moderated Q&A. We have given each of the panelists a heads up on what these questions are, just so that everyone can be prepared. And all these questions, as I mentioned earlier, came up through the subgroups. And some of them were in common. In particular, this first question that I'll be asking, but Brenda and I will switch hit on the questions. These are intended, again, to be addressed by each of the 5 panelists. So given the time, if you could keep your answers or your responses succinct, that will help us to get through all of the questions. So with the first question, it's combined from subgroups 2, 3, and 4, and has to do with sharing data. So it's multifaceted here, and hopefully you can remember it all. So first, the question is, are you willing to share acoustic data with certification authorities to support development of an appropriate noise certification basis for your prototype aircraft? And part 2 of that, if you can remember it all, is what about sharing data with NASA or other research organizations for acoustic model validation, development of test methods, and understanding public perception? So let's start with Ben.
Our position is the same for both questions regarding certification authorities and academia industry in general. We are willing to share data. Obviously, there are stipulations regarding the intellectual property sensitivity, so we would require assurances of anonymity of the data, particularly if it's going to be used in a public forum.
And then, for Joby, we have been sharing data with the FAA and obviously with NASA for the flight test. And again, with the NFAC test, we'll be sharing data with them. We're not going to provide data for intellectual property reasons in an open forum, completely not sharing geometry, for example, for validation studies by outside parties. But we definitely are showing validation studies and want to continue showing that in public forums like this.
From a Supernal side, we don't mind, I have to iterate like what my colleague mentioned. We don't mind to share data, but with some preservation or conservation, like what my colleague from Archer mentioned, with some proprietary IP kind, like especially if you are still in the early design phases, you don't want to share like early design details, but once you have started like some sort of like pre-production vehicle, you don't mind to share some of this data.
Okay, Till or JD? How about JD?
Sure. We're just like the others. We're willing to share what makes sense. What doesn't make sense, we aren't going to share, but both with academia, NASA, other government agencies, DoD, we are definitely willing to share.
Yes, and like I mentioned already, we have been sharing quite a bit data with EASA mostly, a little bit with FAA in the past as well. And we're as long as things are confidential, etc., we are also very open and happy to collaborate on research activities and such things.
All right, I'll take the next question. Steve gave me instructions to do the opposite of what he did, so I'm going to start doing the exact same thing Steve did and ask a compound question. But they're related, so you folks are going to do just fine. All right, considering noise regulations typically require reporting of the noisiest configurations, can you easily identify the aircraft flight profile producing the highest noise for your vehicle? How many operating conditions, i.e. general flight conditions, does your vehicle have? And the last part, are you interested in establishing the idea of standard operating conditions? This is a combined question from subgroups 3 and 4, and I am now going to reverse the order. So we're going to go the remote panelists first, so let's start with Till.
Okay, yes, we do know what's the loudest condition. This is usually always as I mentioned, the transition from a hovering phase into a forward flight, because you're still at maximum thrust and you do something crazy and dynamic with the inflow field. So that comes on top of things. We are, like I said, looking at takeoff and flyover and approach with the Chapter 13 of the regulations. Yeah, so this is, as far as we're concerned now, these are the standard operations that we look at. That's fine.
JD?
Sure. Again, we don't have something flying. Our guess right now is that takeoff for us is going to be the loudest. Personal opinion and just kind of what I'm pushing within the group is, with the battery and being able to manage the battery system and what it's doing, how much energy is there, we pretty much all feel that you're going to have standardized approaches, and they're going to have to be controlled by something other than a pilot. A lot of times we talk about it and we call it free play mode. Will this vehicle, so the Nexus, have a free play mode where a pilot can get in there and just kind of do whatever they want? And most of the time in our debates, the answer comes back as no. They aren't going to ever have the opportunity to do that, because you can just burn through too much energy if you stay in a hover too long. So that's where I'm at on it, or we're at on it.
All right, we'll go in reverse order with the panel.
Yeah, in addition to the hover operation, which is the worst case scenario for the noise, I would add to the descent where there is the potential for a blade vortex interaction. That will be in addition to the hover operation.
I will say we're mostly focused on takeoff and landing noise. It definitely isn't easy to find the loudest configuration. But in terms of like standard operating modes, I think that's very difficult for different concepts. For us, there's hover, and then there's high-speed flight, and then there's everything in between. And everything in between, we've got 6 propellers. They can all tilt. They can all change RPM. They can all change blade pitch. So it's not a unique situation at any of those speeds. So it's very complicated there.
All right. I would echo what some of the other panelists have mentioned. We are expecting takeoff to be our loudest condition overall. The vehicle is designed to operate both as a conventional takeoff and landing vehicle as well as a vertical takeoff and landing vehicle. VTOL, as the other panelists have said, comprises hover, transition, cruise. The notion of standardized operating procedures is something we are interested in establishing for certification, but not as a standard operating procedure in the wild.
Thank you.
Okay, so the next series of questions are going to be directly from the subgroups rather than combined in some fashion. And so we'll start at the top with subgroup 1, and I'll direct this first to Jeremy. I think it's an easy one for you to answer, and hopefully so for the rest, but on what research areas would you like to see academia and/or government focus to help with vehicle acoustic issues in your industry?
Yeah, so this is part of why we had the presentation yesterday, is to show noise source identification, broadband noise predictions. We are also partnering with a university team led by Boston University, Virginia Tech on a NASA ULI to understand the different trim states. Aircraft like us can trim at any airspeed at different ways by changing tilts and RPMs and blade pitches, and so we want to figure out how to optimize it. We also want to understand when we're operating in an urban canyon, what's the condition that might be more or less sensitive to gusts, so that we can make sure that we're not just right on the precipice of a bad noise event if there's a little bit of a gust. So certainly research in those areas, broadband methods, the BPM method, improvements to there, and definitely more research into propeller noise and more details as to what different geometries. We're not really a helicopter rotor. We're not really a propeller, in terms of like a standard fixed wing propeller. So we got a little bit different physics. We got a lot lower tip speeds. So there's Reynolds numbers issues, transition issues. So definitely a lot of areas for research that we're trying to encourage.
Okay, Yahia?
Yeah, in addition to what my colleague mentioned, I would say most of our research now in the eVTOL focus more on the exterior noise, community noise side, and they overlook the cabin noise, the open rotor impact on the cabin noise, which is significant. You have multi-rotors sitting outside the cabin, which is very close to the skin of the fuselage, and the transmitting noise into the cabin. That will be very significant to mitigate. How to attenuate these noise levels from the helicopter levels, that will be a challenge. And that will require developing technology from the passive active noise cancellation into the cabin to maintain like what we call ride comfort for the passenger without the need for a headset like in a helicopter kind. You want to achieve some noise level similar to the conventional commercial airline, like when you have like a 737, or you don't want to go higher than that levels. If you achieve lower than that would be great, but I don't think will be achieved at the first generation. So development in that regard for the cabin noise, I think would be very worthy to consider.
Thank you. And how about you, Till?
Yes, I think most things have been mentioned already. Yeah, new modeling approaches are very interesting that try to capture different flight situations and maneuvers, dynamic effects, especially the changing inflow conditions and flap RPM configurations. How to physically model these things. That's it's very far out. That would be awesome.
And JD? I'm sorry.
Yeah.
Go ahead.
Maybe I can add a specific thing for us, since we have adducted geometry. It's very interesting to see how and to investigate more systematically how the cutoff behavior can be or is influenced by an asymmetric and also dynamic inflow field, because that is a sensitive phenomenon. Yeah.
Thank you. Okay, JD?
I think everything that's been mentioned so far is worth people looking into, organizations looking into. The only other one that I will add is, that's been unique in us tossing around ideas and trying to get a better understanding is prop sync, and how prop sync is going to work within the motors, within the way that the aircraft is put together, within the amount of propellers that we have and how many blades. And for us right now, a lot of it will be just we need to get the aircraft up in the air and start figuring it out. But again, I'm sure there's organizations out there doing it. I'm sure that you all have done some research into it, but that's a big one for us.
Okay, how about you bring it home, Ben?
All right, I think there were two that I'll mention on top of what everybody else said, both of which are being discussed in this working group and in these technical meetings. That is the evaluation of isolated motors, accurate torque-driven motors, being able to understand those noise sources without having a rotor installed is a very challenging discipline. The other one is just understanding community perception, public annoyance. The recent environmental survey didn't do any benefit to our confidence in what the public perception of these vehicles is, so understanding what's driving that perception and more specifically how to quantify that perception, what metrics will accurately reflect the perception of the community around the operation of these vehicles.
Thank you. Steve's testing my ability to shuffle the deck here. So we're going to mix it up on the order here, and he'll test me at the end, see how well I did. This comes from subgroup 2, one of my favorites. What would you like to see included in research studies by external organizations for full-scale testing? What information would be relevant and most useful? We are going to start with Yahia.
Yeah, that's a good question, and I would say what we have followed yesterday from the ideal number of microphone array, that would be really good for full-scale kind testing. What is the best array kind? Is it the snapshot, which was already talked about, or just a circular array, which was talked about at Glenn at some point 2 years ago? Of course, not many people will be afford to buy all this mini microphone array. So you will have limited, you will probably go from like 50 to 70 max microphone. So is there any, I would say, standard way of flying over a noise test for a hover operation especially, or transition in addition to the flyover noise? Hover is not really required in certification, but FAA will require to provide them some data from hover at certain, that's just for informal communication, like at some point in one of the acoustic technical working group, before they require the OEM to provide them with some noise during hover, although it is not part of the certification. So is there any way to develop a standard way for OEM to provide this, whether it is of course it is a single microphone. There is the commercial airline is established standard ways of performing flyover test, but for eVTOL it's still not well defined whether we use the existing methodology in the CFR chapter 36, part 36, whatever it is, like for tilt rotors or for rotorcraft. What if you have mixed separate lift crews, like tilt rotors and the lift rotors? What do you use in the certification? Is it some of them, if you are under 7,500 pounds, you only use the flyover noise point. But if you are above this threshold, you will have to collect the three points: the takeoff, the approach, and the flyover. So these kind of questions I would be interested to know more answers about.
Ben, next.
The largest, I think, gain we could hope to see from that sort of research is in-flight noise source modeling, or I should say improvements to those capabilities, understanding what each of the elements of the vehicle is contributing to the noise profile.
Let's do JD next.
I think for us, it's also materials. So as a propeller goes over a different material, what is that acoustic profile? And then also if there's different hole patterns there, or different shapes where air can actually go through the structure, does that actually change the acoustic signature of the aircraft? And what does that look like? That's it.
Jeremy?
Yeah, I would say we'd love to see full-scale aircraft But the challenge of this industry is that all of our aircraft look different. The aircraft that might be of interest to me isn't probably going to be an interest to other companies. But definitely the more data that's out there on open geometries and of full scale or at least large scale, it was definitely very valuable. We'd love to see more data from full scale testing either in a wind tunnel or more flight testing.
And Till.
Yes, we would obviously have a greater interest in ducted fan full-scale aircraft, and there a variety of flight situations of dynamic maneuvers and different operations in transition.
Okay, this next question from subgroup 3 is actually bordering on subgroup 4, but we'll go ahead and ask it. And how about we'll take it first from JD. The question is, are you concerned that regulatory requirements for UAM noise levels, when they're established, will not be relevant to the needs of communities in which the UAM vehicles will be operating? So in other words, are the regulatory requirements going to satisfy acceptability in some way?
So part of you just cut out during it, but I think I can answer the question. So, I think as an industry, for this industry to go forward, there's going to have to be regulations put on it for the noise, because just for a quick example, I live at the end of Mid-Continent Airport, at the end of the runway. I'm quite used to jets and turboprops flying over. Most of the time I won't even look up, but if a helicopter goes over, I will look up, or I'll go to the front door and see what kind it is. Again, we can't have these things flying everywhere all the time and making all kinds of racket like we have in the past. So I would say, yeah, definitely. We need to have the ability to have a strict rule or regulation that tells us what we have to meet. And I think everybody should have to meet that same goal.
Okay, and since, Ben, you kind of alluded to this one in the previous question, why don't you take it?
Yeah, we are very concerned that these regulations are not going to be beneficial or practical in terms of limiting the noise. The standard that is currently called out in the FAA Part 36 Appendix K references the Stage 2 limits, which were introduced in 1988, which is when I was born. So they're pretty old. Certainly if there was a vehicle to enter operation meeting Stage 2 limits, but not with much margin on those limits, they would absolutely, I think, destroy the business case for our whole environment. So certainly we need to look at establishing more stringent regulations than what are currently in place.
And Till, from your perspective?
Yes, 1 second. Yes, we are, especially in the dialogue with the local authorities, we are quite happy about the process, and we're very invested in the dialogue. Like, there's also EASA opened up this innovative air mobility hub where they actually integrate the citizens and the local stakeholders into the perception of new UAM noise and possible concerns, etc. So we are always very interested in having an active dialogue with the authorities there that will help to integrate all the interests and balance out the interests there. So I think for the regulatory requirements, that will be a balanced thing in the end.
Okay, thank you. Yahia?
Yeah, I agree. There must be some sort of regulation to, especially when you are flying into suburban environment where you are very close to the people. It's different from flying from airports. But at the same time, I look at it from a different way, that you are still new market, new technology, and you don't want to start from a very stringent regulation that, especially in the first generation, you will start with existing, and gradually you implement more stringent requirement over the time as the technology or the market mature.
And Jeremy?
Yeah, I think this is an important challenge. The question is going to be whether there is going to be a one-size-fits-all national standard, or whether it's going to be every single little city, municipality, and county and little area. I think certainly initially it'll probably be much more of a local situation, and there's going to be challenges of local communities and communicating with them what's their noise sources. There's a presentation the other day about the National Park Service and about how they're doing Grand Canyon operations and how they're regulating them and giving different slots to different aircraft, and how quieter aircraft get more slots. And I think that's something that might happen in future vertiports that are in more noise-sensitive locations, that they might say that this aircraft can fly, this aircraft can't, or this aircraft can fly this many times a day, and this aircraft can only fly a few times a day. But I don't really think there's going to be a one-size-fits-all national standard where they're going to set some limit, and that's going to be enforced across the industry. I'm quite highly skeptical that people in certain locations are going to accept a federal standard when they're going to want to write their own, or they're going to want to have their own rules for, how many people that nearby there are complaining. So it's really important for our companies and our industry and government to have communications with these local communities and explain to them what's going to happen in the future, and so that it's not a surprise and that they're involved in the process from the beginning.
All right, question from subgroup 4 is somewhat related to what you just answered, so this will be an easy one. Considering that there are currently no noise regulations prescribed for urban air mobility, which 14 CFR Part 36 Appendix, ICAO Annex 16 Chapter do you consider a best fit for your noise certification of your product? Appendix FG, fixed wing, Appendix HJ, helicopter, Appendix K, tilt rotor. So I am going to start with Jeremy.
We're obviously pretty far along in the certification process, and we're using Appendix K. So the K for tilt rotor. So
That was a short answer.
Yep.
We'll go to Ben next.
We are still in discussions with the FAA on which chapter or chapters to proceed with. As I said before, our vehicle has the ability to operate both as a CTOL and VTOL aircraft, thus both the Appendix G fixed wing for CTOL and Appendix K for vertical takeoff and landing would apply. I will add, though, that the language in Appendix K is quite explicitly written for what is now the Leonardo 609. It assumes a very common operation for that vehicle that doesn't apply to, I think, any of the current vehicles that are being designed. So there's a bit of rework that has to be done in establishing a cert basis based on Appendix K.
JD?
Ben kind of answered for eAviation, even though he's not a part of it. I appreciate it. Same. It's duplicate of what he said. Nailed it.
All right, then I'm going to move right on to Yahia.
It's very easy. If you have all tilt rotors in your vehicle, you choose subpart K because it is for tilt rotors. But if you have like mixed left rotors, tilt rotors, what do you use? Would you use the helicopter rotorcraft, which is the part J or H, which is not applicable? So would you use tilt rotors because you have tilt rotors in your vehicle? So that's uncertainty in this area.
Till?
Yeah, like I mentioned already, it's chapter 13 of the ICAO's annex, and with the concessions or deviations communicated through this special condition.
Okay, thank you. And we're going to go back to subgroup 1 and go through another rotation here. So this has to do with tools. What computational tools are you using for low, mid, and/or high fidelity acoustic simulations? And do any of these tools affect your acoustic design? Hopefully so. And if you are not using computational tools, what features would they need for you to use them? So how about Hill?
Yes, so yes, of course, we do use computational tools on basically every level. So we do have scale resolving source tools in the type of LESDS that we apply. Then there's a lot of analytical semi-empirical modeling of to try out quick design optimizations and predictions. There's again, discretized propagation software that we use, more focused at the cabin noise concerns. So how much do our engines radiate noise towards the fuselage? And finally, there are maneuver modeling, far field tools that will that project our measured or computed noise on an engine level towards the flight envelope of the aircraft. Sorry, I can't mention more names. Yeah.
Yep, that's fine. Jeremy?
Yeah, so our blade was designed mostly with overflow. So I was running a lot of overflow and wop-wop for hover noise. But the broadband noise prediction stuff in those tools aren't very good. They weren't enough for us to help with the design. So obviously we did a lot of testing. In terms of high fidelity, I think we showed the other day, we're using overflow and wop-wop for flyover noise for high fidelity. Where for low fidelity, we use RCAS mainly for structural dynamics, but there's some error that comes out of that. But we're really trying to, part of publishing this data and with the flight test noise is we're going to look at more tools, more fidelities of tools to try to figure out what those tools can predict and what they can't predict. I think in general, we need to probably go to higher fidelity to get more accuracy, but it's about whether that helps us. Right now we're focused on our takeoff and landing noise, so we want to try to find a good tool set and a methodology for improving our takeoff and landing noise.
Ben?
All right, lots of comments. Okay. For the aerodynamics, in terms of low and mid fidelity, high rapid turnaround, we're using the dust tool out of Polemy. I always butcher the name of this. The Milano Polytechnic Institute. It's a vortex particle method. Very rapid solutions, high accuracy. When we go to high resolution, we do use overflow for verification, validation, but we're seeing good agreement between those two tools in general. For the acoustic designs themselves, in terms of broadband, the lowest fidelity, there are, when you make a few limiting assumptions about the design, there are some closed form solutions that allow us to at least understand that space and where we can feasibly design the rotor. The tools that we're particularly using are the Brooks-Marcolini method and a in-house build of UC Davis's Quiet Fly model. We're seeing good results from both of those. Admittedly, the BPM model that I'm using is also built in-house and has some modifications that improve some things to it. In terms of tonal, we are also leveraging PSU wop-wop across the board. It's a very capable tool.
Okay, Yahia?
Yeah, we use different levels of fidelity. It depends on where we are in the design phase. So early in the conceptual design phase, we use just simple Excel sheets, like based on earlier NASA based model like NASA Goten, simplified models. That's very early in the design phase. Once we get deep into the design, we use some sort of like mid fidelity, like charm for rotorcraft noise prediction. We use it mainly for like tonal noise. Of course, with wop-wop or a PSU up-hop. If we go high fidelity, once we have more defined design, more detailed design, we go to CFD-based, like star CCM or power flow kind simulation. We lean into more star CCM, especially for the higher tip speed. For broadband noise, we use both NASA and OP2, and we use QuiteFly as well to give us some fidelity, like mid-fidelity kind prediction.
And JD?
So we're the same. We kind of use the standards of what have been mentioned. The things that are a little bit unique about us is Bell having 80 years or so of history. They have been creating their own databases, and then on the Macaulay side, I think actually 100 years of experience. They've been creating their own databases, and then also the same with Textron Aviation. So with that, as I mentioned before earlier, though, we haven't paid as much attention to noise as we are right now. So as far as what we're predicting and what we're actually seeing, that's what we still need to get on the test stands and understand. So we believe that our in-house databases are going to be, they're going to work, and they're going to work well, but again, they haven't been validated.
All right, we'll move on to subgroup 2. What is the most important aspect of the vehicle noise and acoustic testing do you need to effectively address community noise in the vertiport? I'm going to make my life easy. I'm going down the row. So, Yahia, why don't you go first?
Yeah, I think one of the important things regarding vertiport operation will be what is the acoustic footprint will be modifying the surrounding around the vertiport with the operation of these eVTOL vehicles.
Jeremy?
Yeah, definitely takeoff and landing noise. That's why we did the national campaign test with NASA. It was focused on a lot of different approaches and departures. So definitely that's the area where we're going to have to be communicating with the communities and understanding what's the best way to operate and what's our noise levels in those situations.
Ben?
Pretty similar answer. The operation types, so the ingress and egress, the number of flights, the perception of safety of these vehicles, as well as the demographic, both the topographic layout, whether it's a canyon or an open environment, as well as the community makeup. So whether we're talking, industry, hospitals, highways, each of those will affect it.
JD?
So I think in the past, how it used to be with airports, at an airport in a major city would go way out in the outskirts of town, and then slowly, housing would build up around it. And then from there would become complaints, and then there would be new regulations. What's unique about this is we're trying to start in cities, in more populous areas, and what that's going to look like with the perception, like has been already mentioned. But we're having that feeling that, hey, look, we aren't going to be going out even further into town with these. We're going to be going in closer. So, keeping them as quiet as possible is going to have to be one of the number one requirements, again, to get acceptance. I keep going back to that. For us to get acceptance of the industry that we're trying to create, we're going to have to be quiet. Thank you.
Till?
Yeah, and of course I can only agree. It's about acoustic footprint that we want to minimize, especially in takeoff and landing conditions. But it's also about a feedback of perception of psychoacoustic aspects of stakeholder neighboring communities, perception of the noise nature that is of course interesting to us.
Okay, the next question has to do with ConOps a little bit, and that is from what we've seen in videos and so forth, and certainly flight tests, everything has been during the daytime. So this question is from subgroup 3, are nighttime operations, that is those between 10 p.m. and 7 a.m., part of your ConOps? And if so, what can you share about differences between how you intend to operate during the daytime versus at nighttime? And why don't we start, Ben?
So I will defer to our ConOps designers. We're using a tool that we built in-house called Agility Prime that is assessing the availability, the market, the needs of transportation, hours of the day, days of the week. So not trying to skirt the issue, but it's something we're still assessing as to the individual needs of each market, whether or not it makes sense for us to offer such operations at night. If there's no demand, we're certainly not going to try to make it available. In terms of operating at night, we are sensitive to the increased sensitivity from the public, so we are making the pretty standard assumption that's applied in the DNL metric, which is a 10 dB increase in that sensitivity during that period.
And Jeremy?
Yeah, I mean, we definitely are looking at those type of operations late at night and early in the morning, but again, it's only where it's economical. So yeah, I think you can imagine that people take off and land at an airport at pretty early and pretty late. But obviously, it'll depend on the vertiport whether we operate early in the morning or late at night for economics and for noise reasons.
Yahia?
Yeah, it will definitely impact the business case, will limit the operation during this night time, but it will depend on mostly on the local regulations, because not all local regulation will be like very strict. Like some areas are very strict to fly at night, so these areas probably will not be feasible to operate at night. But some areas, they are more no specific regulation, so it will be depends on where you are.
Mm-hmm. And JD?
So we plan to operate round the clock too. Again, it all plays into what the business case looks like. Again, right now, as far as we're planning that we would be a provider of the aircraft, somebody else would be the operator, but the intent is to operate round the clock.
Okay, I think we planned this out pretty well. So Brenda, there's one more question. Thanks, Ben. From subgroup 4.
I'm out of note cards, so this has to be the last one.
All right.
And after that, we'll open it up to all of you. This is from subgroup 4. It is uncertain when noise regulations will be established for the emerging UAM, AAM market. Are you more concerned with stringent noise regulations may be imposed unnecessarily limiting the market, or that noisy aircraft could be entered into service, negatively impacting public acceptance of the market? And I believe we will finish up with our remote ones first, so we'll start with Till.
Yes. So like I said, we are in this close interchanging process with EASA and with local, sometimes with local authorities, more with national regulatory authorities to coordinate with the local stakeholders, and even through this IAM hub, there should be guidance for communities. And so for that reason, because it's a very integrative process, we're not concerned too much in either direction at this point.
JD?
So for us, I mean, public perception is going to be a huge part in acceptance of these aircraft, especially initially on. If we go out there and, again, safety has to be of utmost priority, but then after that is where are they going, where are the aircraft landing, and then how loud are they? If we go in and we have something where they're allowed to be relatively loud, and we start getting a lot of them out of there, I think that we'll end up having quick restrictions put on us anyways. So to me, let's start with the, as quiet as can be, start getting the general public used to what we're doing as we're, out doing test flights, as they're starting to see these for the first time. Again, to most people, they're going to be quite unique anyways, because most of them don't even look like a helicopter. We're going to have to be working with the public a lot on this. So that's where I'm at with it. We have to do it first. If not, we'll kill our own industry.
Yahia?
Yeah, I would reiterate with what Terry mentioned. I'm not really concerned about the certification based on the existing levels, but I would worry more about the public acceptance.
Jeremy?
Yeah, I mean, we're pretty far along the certification path, so we're not concerned with that, the levels there. Obviously, these aircraft aren't going to all of a sudden, appear by the hundreds in every city. They're going to be city by city, slowly introducing them. So it will be incumbent on the companies operating in those cities to operate quietly, communicate with the cities. I think it'll be an interesting dynamic whether people differentiate between different aircraft or whether they're all the same. But yeah, it's going to be a challenge, especially as we scale up to bigger and bigger operations, newer and newer cities, more heliports, more operations at each location. So definitely will be a challenge. Obviously, noise is very critical, and that's why we've been involved in this quite a while, and that's why it's been a major priority in every focus of our design.
Ben?
So the current regulations, the trend in the regulations doesn't give us much concern in the way of being overly restrictive or limiting our ability to certify the vehicle. But I am very concerned that the lack of stringency will allow people to, operations to exist that will offset that public acceptance. I think there is a nuance that perhaps engineers apply to the difference between these vehicles and helicopters. We see them as being distinctly different. I think the public will see them as simply something that's loud, that's flying around. And so it's a very quick jump to say that, well, they're pretty much a helicopter doing the same thing as a helicopter, almost as loud as a helicopter in a bad situation. And if that is the progression in the mindset, then that will almost certainly lead to a severe restriction of our ability to operate.
Thank you.
Can I add something?
Sure.
Yeah, what Rob Stoker actually showed in the first day about the Schultz curve, the perception of the people, which was 90s, compared to what is the national survey, the recent one, very alarming, which means that the people perception to the noise is changing. It's not like 65 DNL is acceptable level. It is even lower than that, so which is very alarming for us.
Thank you for that comment.
Okay, so that concludes the moderated portion, and hopefully there are a bunch of questions that have come up in the chat. James is shaking his head over there. I will just, as we open this segment, say for the in-person attendees, please state your name and organization when you're asking a question. And as much as possible, please direct your question to a particular panelist or panelists so that everybody gets a chance and we can get through as many questions as possible. And then lastly, for those that are online, use that thumbs up to elevate the question to those that are most important. So with that, how about a question from the audience? Sandy?
Thank you. I'm Sandy Lancaster with Dallas-Fort Worth Airport. I've been working in noise for over 30 years. Obviously started when I was 12. And the one thing I've noticed, obviously noise is subjective. And it's very difficult to predict how people will react. So number one, oftentimes you do outreach to people, but they don't really feel like this is not going to affect me, so you can't really generate the interest when you're trying to be proactive. But then if you implement the flight and they don't like it, now you've got a public issue that you did your best to avoid. So it's getting the right folks to the table and help them understand how this affects you. I mean, that's kind of a key component. The other thing I've noticed is, particularly when you focus on broadband noise, the loudest aircraft may not be the one that causes the challenges. Back in the day when they used to fly checks at night, some of our biggest offenders from the community were GA prop aircraft. It was the time of day they operated. it was the prop noise, so not loud, but it was a frequency issue, tonal issue. And so those are some of the challenges that I've seen as I've worked in noise, is really trying to understand how the community is going to react and be as proactive as possible, and then recognizing it's not all about broadband, it's about many other factors. So I appreciate everybody's comments, and I really appreciate the keen awareness of really engaging the community and getting that public acceptance so that this industry could move forward.
Thank you, Sandy. James?
All right, so I've had some time to collate the questions that came in online, and I'm going to apologize to Steve. This is going to be to the entire panel. But Lothar Birch from DLR, Roald Almoaz, and Duran Bogalt, I'm certain I've butchered all three of their names, have very similar questions. So we understand, right, each UAM vehicle is acoustically unique and substantially different than other air vehicles that are out there. So does the day-evening noise level or the day-night level contours appropriately capture the events from UAM vehicles, especially operated in larger numbers? What do we need to capture more than just simple A-weighting type things? And then what psychoacoustic metrics do you think are useful for your particular vehicles? So 3 questions in one, and for all of the panel.
I kind of want Duran to answer all of those. He's the expert on all of these. So let's say you asked about DNL. DNL is certainly a first order. We are looking more at the time variance of the signal, which is not captured by that. There really aren't any metrics that are capturing that as a whole, beyond just looking at deviation from a mean to a maximum. So I would say a metric that captures the time variation of the signal is certainly one that would be needed to give us more confidence that the community will be able to accept these levels.
Yeah, I would, agree. It's important to understand the metric in the context of the ambient environment that a person's in. DNL is not overly useful, I would say, and it's not. We want to make sure that noises are, how a person hears a noise is in their environment, and whether it's, as Sandy was saying, whether a helicopter is quite loud and it is disturbing, where maybe its A-weight level might not be that different from another aircraft, but it's very disturbing. So we've definitely designed our aircraft to try to reduce the tones and try to blend in with the environment. You're able to hear flyover noise, and obviously we're focusing on that and trying to understand with different metrics, whether it's blend or time varying loudness, and very much supportive of research efforts and outreach efforts to different communities to play the sounds and to have them introduced to what the sounds are going to be before they're getting introduced, and so that we have some community feedback and engagement early on in the process is really critical.
Yeah, I would say day and night level is a daily average dosage of the noise exposure, but it's not quite represent the annoyance. So that's why in our subgroup 3, we are working in trying to come up with like a metric for eVTOL. Currently, for Supernal, we use the existing metrics in the certification just to be close, like dBA kind, if it is like EPNL kind, effective perceived noise level. But would be good if we can find out whether these metrics are applicable to eVTOL, or we might think about other different metrics.
Till or JD?
Yeah. Oh, sorry. We just. Oh.
I can just break it down and just my thoughts. It really comes down to, on the chief engineer side, is it annoying or is it not annoying? And is it loud or is it not loud? So if it's perceived to be loud and annoying, that's definitely way worse than it being, relatively quiet and annoying. In the end, we're just trying to get to quiet. So That's where I'll break it down, but everybody else on the stage was, very similar answer too.
Yeah, same for us. Like EPNL is an interesting metric. We are above the DNEL. We are interested in single noise events that should not be excessively loud, and so the dynamics of the phenomenon plus tonality is obviously a factor that we pay attention to.
I'd like to circle back to Sandy's question. Sandy, or statement, I didn't hear the question so much, but it's fine. Out of that, though, I formulated one, so I'm, being up here, I could take the liberty to ask it. And I'll ask it of the those that are out front with vehicles, so Ben and Jeremy and Till. What kind of outreach activities are you thinking of as you field your vehicles?
So actually, Joby and I had or I should say Archer and Joby had a similar series of presentations, very close in timing, showing off the operation of the vehicles, introducing the public to the vehicle itself, the concept of the operation, as well as a nominal operation of the vehicle in an airport setting. In terms of how we are going to introduce the larger public to it, Archer's approach is somewhat of a soft open, which is introducing these vehicles in existing routes, routes that the public wouldn't be surprised to see a vehicle flying through. So as I mentioned, Newark and our Chicago routes, those are not going to be a surprise. It will slowly introduce the public to these vehicles, and we can use that as a driving force to then engage the community further and provide more information.
Yeah, I'll say, we want to reach out to local organizations, particularly local politicians, local city council members. One advantage that we have is we fly in public almost every day, and almost every day we have representatives of different organizations coming to witness the flight test and to really see it firsthand and to hear it firsthand. Watching videos on YouTube are great. Watching, headphone experiences that we can bring to different communities is an important way to reach out to different communities and sort of explain to them this is what it's going to sound like with high confidence, because these are actual recordings. But yeah, I think it's important to reach out both to local communities, local politicians, and really try to get their buy-in from the beginning about the benefits this new technology is going to bring.
Yeah, similar for us. We are interacting with the aviation agencies and also national authorities to have them with flight tests as possible, and mostly work through that, and obviously YouTube videos, these kinds of things at the moment. Yeah.
Thank you. We have a question.
Jim Potter, Department of the Air Force and Chair of Defense Noise Working Group. I've got a bunch of questions. But let's start with data transparency. I heard all of you say that, and let's focus on Joby to make Steve happy. I heard all of you say you had confidentiality concerns, but my concern is that the federal government can't buy any of your products unless we can get through the National Environmental Policy Act process, which requires everybody to show their homework. So what are the limits of your data sharing, data transparency, and when will we be able to get over that so that we can buy your products and allow you to use the National Airspace System?
So I'll say various entities of the U.S. government do have full access to our data. I'm not particularly sure if you have access to it or not.
DoD doesn't, to my knowledge.
I think there's some issues with that, but we're being as open as we can, and things will change. For that type of certification, operating the national airspace, it's going to be flight test, and we're going to have to show that data when that happens. But that'll happen with the certified aircraft. How much of that's relevant with our pre-production prototype? Some of it is, some of it's not. Yeah, we're showing a good amount of data.
I can throw in there on our side. Of course, we sell stuff to you. It seems like every other week we're selling the government something new. We train the Air Force and Navy and the Marines how to fly, and we also have many aircraft that we deliver as far as special missions are concerned. Our data is open, and we are definitely willing to work with the government on whatever they want to see.
Okay.
Yeah. I've got a question for you. Maybe Joby and Archer would be just to start if you want to keep it kind of small. Maybe one's a comment is you all kind of talked about DNL not being right, but you're planning on flying in and out of a lot of airports as a starting point. And they're going to be going through Part 150 studies, so you may want to really think about airports and the DNL contour. And then as you go into those things, I would say talk to some of the groups around there. There's a lot of anti-noise groups at the various airports, and you'll get a very different kind of reaction from folks. And you all talked about certification not really being your concern and being able to certify the airplane, and it's more about public perception. So I guess the question is, how quiet do you think you need to get to be okay with public perception?
Yeah, if I had an answer, if others had an answer, I think everybody would already know it. We are working within the boundary conditions that are apparent. So obviously the certification standards as they exist are not sufficient, right? That's a known upper bound. The lower bound, the target, ideally would be ambient, of course, right? I mean, if we can blend behind the ambient, then there's no impact, and we're done. The open question beyond that is how high above the ambient is acceptable, both for single operation and continued use, and how close is that to the certification standard versus ambient.
Yeah, I'll say, we've demonstrated 45 dBA for flyover noise at 500 meters height, and then at takeoff and landing noise, 65 dBA at 100 meters away. That's just what we've demonstrated, but obviously those are just dBA numbers. It's important to understand how they're interfacing in the background noise of the community, and whether directly where the person is matters. But we're working with those rules and those regulations in local communities, and I think we want to be distinct from helicopters as much as we can, but that's what people want to compare us to, and we need to have good comparisons to those aircraft, which is partly why we have that video where people can hear. And when we showed that video, we didn't show numbers. It was just, what do you hear? What's your perception of the noise? And I think that's a sound quality, and I think that's very important when we're talking with communities, is to actually play noises.
Okay.
Anyone else on the panel before we go?
Yeah, we try to design to be around the 65 DNL level, but based on the national survey, 65 is not adequate. So you have to make it even quieter than 65, which make it even harder and challenging. And if we talk about single event versus multi-event, how many operations will limit the operation around the vertiport? And it depends on the vertiport selection at the same time. If your vertiport close to a highway where your ambient is very high, so that will give you some margin for operation. But if you have it in near like a residential area where the ambient is very quiet, of course it will limit your operation.
Okay, let's take one more from the audience, and then we'll go back to the online. Go ahead, Bill.
Yeah, yeah, Bill here, FAA. Question on further noise reduction, particularly in the operation side, like that fly neighborly that we see today for helicopters. And so what do you see as a potential down the road to opportunities? And on the operation side, how can you reduce the noise specific to noise-sensitive points?
Is that directed to any particular panelist?
No, we can start with Ben.
Okay, cool. Let's see. There is, sorry, I'm processing the question. So our vehicle is designed for pretty simple, pretty low pilot effort. So to that end, we are designing a trim line that will be optimized in a number of regions, not the least of which is of course power, but of course optimizing the trim line to provide a quiet profile, such that it doesn't take extensive knowledge from the pilot, extensive training to operate in a quiet manner. I would say conversely, it's beneficial because that means that it's actually harder for the pilot to enter into a high noise operational state, whether knowing so or not. So providing that restriction, or at least the optimization such that general operation of the vehicle will maintain a quiet footprint. As well, there are certainly profiles that can be flown. The fly neighborly for helicopters has shown similarly. The manner in which you fly in and out, the rates of climb and things are very impactful on the footprint. So that can also be a applicable approach for us.
Yeah, I'll say our control system, we don't have a pilot that has 6 arms that's going to control each tilt and each RPM and each tilt. So it's going to be the software. And so there's certainly a lot of research and development into the software over the next couple of years to fly as quiet as possible. That's, again, partly why we're working with academic research on trim for how to take off and land in a robust manner. But it's going to be the software on the aircraft, and that's subject to, that's why we're doing a lot of flight tests. And we were able to get a lot of data out of the national campaign test of a lot of different takeoffs and landings, and really understand what makes a better one or a worse one, and try to develop metrics. But it's also going to have to be customized a little bit to the vertiport, where you might be more or less sensitive to certain noise areas at a particular location. So it's definitely not going to be a simple solution or customized to different locations in the aircraft, and working with multidisciplinary areas of the company, for whether it's controls, safety, and noise.
No matter you do to make the rotor quieter, you will get to a point where the noise will be an issue based on the operation, the number of 10 vehicles flying at the same time, how many events. So that's why the first generation of eVTOL will be more into the urban, suburban environment. And then once the technology mature, several years from now, 10 years, you can expand this operation into the quieter communities. That's what I'm thinking. Initially, you will not be able to fly in a quiet environment like rural areas. You will be still very high above the ambient. Unless the people will complain, of course. Yeah. Once the people complain, which there was a case in Australia. Google operated a drone, delivery, and the drones were flying very close to the people's houses, and it was very, very loud. So not loud, relatively loud, relative to the ambient. So that's why the people start to complain. So that's why the focus for the first generation will be more into the urban, suburban environment.
And quickly, Till or JD, if you want to chime in on that before we go back to online.
Yeah, sorry. I guess the more knowledge we can gather and understand, especially transient phenomena and flight operation and maneuver details and their influence on noise specifics, together with understanding better what bugs people, what people find annoying in detail, there is, I believe, quite some margin still to further reduce noise and perceived annoyance of noise in the future.
Kind of the same as everybody else, but I mean, when we're starting to put vertiports out there, and we're starting to put together set approaches, I mean, just being simple with it and, having the approach go over a parking lot instead of a housing area are going to be the things that are going to make a big difference. Nothing more to add.
Okay. James.
All right, so we have a question from online from Lothar Birch, DLR. He didn't target it directly, but I will, just to keep this going correctly. So JD, the question is to you. Are you looking into toroidal propellers as discussed by MIT, and can you provide any comments?
So no, as of right now, we're not. I mean, I've watched the videos and they are a lot of fun. But as of right now, we are not doing that.
All right, and I'll ask the next question came from Ryan Bajorek. So this one is to Ben at Archer. You made a statement in your opening remarks that Archer's vehicle will blend into the environmental background noise. Can you share what studies Archer's done that supports that statement or yet to be done? And at what scale have the studies been done or will be done? Also, follow up to slightly related, are you excited to see the Midnight or the Maker vehicle in United Airlines app cleared to land, and now you can play it?
Yes, I am very excited to see that announcement come out. Sorry, the question was about whether or not the vehicle, or how we've established that the vehicle will blend into the background, is that right? So to that extent, I didn't mean to imply that there's been a large series of studies done. Certainly, we haven't done any sort of community assessment of that. What I was referring to is simply the overall levels of the vehicle relative to the ambient. And as Joby has demonstrated already, we have not publicly announced any of this information, but our measurements do indicate that the flyover noise level is below ambient, which suggests that the vehicle will not be heard. On top of that, we are also looking at POD, probability of detection, and to that extent, we are seeing very low levels of probability of detection from our vehicle relative to the ambience in which we are testing.
Thank you.
The discussion of single event metrics and ambient is a little troubling, again, in the NEPA context, because you're all planning to fly, you're all planning to have certified aircraft, you're all going to be flying, and NEPA requires cumulative impacts. So can you speculate a little bit about the value of DNL when all of your aircraft are in the airspace, kind of like those electric scooters that are all over our sidewalks?
Who is that directed to, Jim? One.
Who hasn't had a question yet? Till, please.
Sorry. Yeah, that's a lot of speculation, but I think this is part of the process of finding out if and where there's new regulation needed, and on a national level or even on a local level. And like I said, I think that both tonality and single event noise metrics are of concern, and we try to optimize with respect to those as well, and not just on an overall time averaged approach.
Jacob Gold, Techsburg. There's been a lot of talk about steady state and vehicle-vehicle interactions, but there's been very little talk about gust response or atmospheric turbulence ingestion that are particularly a problem in these urban canyons that the operations are designed around. What are your solutions for that, either from an engineering or a ConOps standpoint?
I'll answer partially. We are working with the NASA ULI, with Boston University and Virginia Tech and Embry-Riddle, and that is one element of that research, is to better understand those effects. But you definitely want an aircraft that's robust and isn't overly sensitive to gusts. We definitely have done a ton of flight testing in different windy environments. The operations that we do now are not at a very low wind environment. The NASA flight test was at very low wind, but we do a lot of flight tests now that are in much higher wind environments to better understand that.
To clarify, I'm specifically looking at the acoustic difference, not the control authority of rotors make very different sounds when they're ingesting turbulent flow.
Yes, the NASA ULI is looking at acoustics in those situations.
Till, would you alluded to the inflow and its effect on the noise generated in transition. Do you want to chime in on this question?
Yeah, this is a key key topic, as I think I understood also from Joby's presentation yesterday, on explaining parts of the noise emission that are that do depend on gusts, on turbulence levels, and this is to me physically on how the inflow hits the fan. This is very closely connected also to motions of our flap and of the variations of the incoming flow field. So it's an expansion of the dynamic flight dynamics.
All right, another question online from Benjamin Bernard, and I'll target this to Yahia. Although acoustics is multi-physics by essence, if you had to pick and focus on one single design parameter or area to improve acoustically, which one would you pick and why?
Yeah, the major parameter for acoustics in open rotor is the tip speed, or tip Mach number. That would be the decisive to impact the acoustics.
Thank you.
I can expand on that, actually.
Go ahead.
Our experience has actually found, both from our own internal work and our competitive analysis, it appears that most of the industry is going to be below at least a hover tip Mach number of about 0.5. So that certainly addresses what Yahia was referring to in terms of driving the levels. However, below 0.5, you start getting some interesting interactions where it's no longer predominantly tonal. Now you do have an interaction of both tonal, broadband effect, certainly motor if there's there. So there is an increased capability to design the spectrum as opposed to having it fall out when it's just being driven by the tip speed.
All right, I've got a personal question. So we're done with the online one. So if anybody online has any more, please add them into the chat. But I'll direct this one back to Yahia as well. So we've seen from Joby over the years that their design has changed significantly. Archer has at least alluded to the fact that multiple design changes have been made. So from Supernal's perspective, do you anticipate, we saw some images today of the vehicle, do you anticipate further design modifications to maybe locations of the rotors or something along those lines?
We're always looking for improvements. We will not stop continuous improvement in the design. And we always looking for, from the acoustic perspective, to get the quietest design possible, which is not only meet the noise certification, but also to be publicly accepted. So we are keeping this in consideration when we design, not just to meet the noise levels, which is like whatever existing levels, but to have a certain margin, or to make sure that the public will not be annoyed by that noise level.
I'll ask one to keep things going here. A little more futuristic thought, I suppose. So retrofitting for noise is a challenge in the commercial subsonic transport area for sure. I think we in acoustics get excited when there's a clean sheet kind of starting point for this industry, which is wonderful. Having noise as a driving design factor in many respects, and coupling that with the Schultz curve changes that we've seen over time, is there any concern, goes to the panel members, that you might see that stair step down, and while certification regulations might be comfortably met now, as the industry grows 10 years from now, you see that stair step down, and are you able to maybe additional noise technology on existing aircraft? Do you go back to another clean sheet? Has there been any thought or concern in that realm?
Yeah, I'll say, continual improvements. The 737, dash 200 and dash, 400, 600, 800. Like, I don't think these aircraft are going to have those small marginal improvements over time. I think there will be different configurations over time, and pretty major changes to configurations. So definitely, I think our aircraft right now, is quiet, and the goal is always going to be to get quieter, get faster, get more manufacturable, get cheaper. There's so much improvement that we can have in the future, and it's really exciting to be, part of this industry at this time where we can have lots of changes and where it's very innovative and lots of new ideas that are tested and tried.
All right, so James Stevenson, I'm going to channel my inner Krish Ahuja with a question he had Monday to the liner folks. I'm going to ask it to you guys slightly differently. So if we could reduce the noise of your vehicle by X dB, right, how much thrust penalty or top speed, range, payload would you be willing to lose to meet that quieter acoustic metric?
The first question, I think, from a design standpoint is, what do I get for it? So I get X number of dB reduction, but what does that do for me in terms of the operation of the vehicle? So sort of back to you, does that enable further operation? Right? I mean, are we already at a point where further reduction of the noise doesn't, greatly affect the annoyance? If that's the case, then, certainly we wouldn't drive toward it. But if there is a means to increase the operation based on lowering those levels, then from where we stand, as long as it doesn't destroy the business case, right? As long as we're still making a profit, we have shown that we are willing to sacrifice on the performance efficiency of the vehicle if it means lowering the acoustic footprint.
And to add to what mentioned, there will always be a compromise between performance and the noise. So performance people will always ask you to increase the tip speed. But we will tell them, no, let us keep it within the 0.5 Mach number to keep the noise levels to affordable or acceptable levels. So there will always be a battle. Like they want to increase to have more performance, but for eVTOL, I wouldn't go excessive in the Mach number, in the tip speed, or the noise levels, because if we bring a vehicle into the market sooner with very loud and the community start to complain, it could kill the technology. So we don't want to rush and they get some loud vehicle into the market, into the urban environment, and people will start to complain, and then no more eVTOL, like what happened like in several other communities. So we don't want to be the noise, to be the decisive factor to make this technology like going nowhere.
Okay, I'm going to interject at this point as we're getting close to the end here. I'd like to thank all the panelists. To my knowledge, this is the first time that we've had a variety of companies coming on at the same time and giving their different points of view. And both Brenda and I, and hopefully you all, really appreciate that fact. We've tried to make it interesting for you, and hopefully that's been the case. If there are any remaining questions that are in the chat, I don't know that there are, but maybe we can get those out to you and you can address those. And again, I'd like to thank you all for a illuminating conversation, and hopefully we can do this again.
Thank you.